All right, so because the video is about making a hypercube, how about we start with, what is a one-dimensional cube?
Square.
No, that's a two-dimensional cube.
Well, it's not a cube if it's one-dimensional.
Right.
Yeah, good. It's not a cube if it's one-dimensional, right?
Yeah, that's fair.
That kind of makes sense. So what is the one-dimensional analog of a cube?
Just like 2 lines. I don't know.
A point.
Point.
That's a zero-dimensional analog.
Line.
How about a line segment?
Fair.
Right? Like a line segment is a one-dimensional kind of square, right?
Yeah.
You guys with me on that?
Yeah.
Okay, so to make a regular square, what do?
You just add the y-axis.
Yeah, you kind of do that in one direction, right? And then you do that same thing at a right angle in the other direction.
Yeah.
You guys with me on that?
Yeah.
And then you take everything that's this much over, right? Over an amount in here and up an amount in there, and you get a square.
Yeah.
You guys with me on that?
Yeah.
So another way to think about this would be to say this is like the closed interval from 0 to 1, right? And then this thing is like the closed interval from 0 to 1 by the closed interval from 0 to 1.
Fair.
You guys with me on that?
Yeah.
Okay, how do you make a cube?
Do it by the closed intervals for the 1 again.
Yeah, you do, okay, so you do the closed interval from 0 to 1 by the closed interval from 0 to 1 by the closed interval from 0 to 1.
So you extend the whole
Right, you're going to go,
and another square.
yeah, you're just going to tack on perpendicular to that thing, right? Perpendicular to both the directions you've already done. You're going to go out 0 to 1. And then you're going to fill in that thing, right? So that makes a shape like this. All right? Okay, so how do you get a 4-dimensional cube? Or a 4-dimensional square, right?
Do it by 0 to 1 again.
Yeah, you just add up, like, okay, so I'm going to go in the next direction perpendicular, right?
Is that in?
I don't know. I don't have a way to draw it up here. You guys see that?
Yeah.
Like, I don't have a way to draw that other dimension here. But what I could do is I could think, okay, so for this guy, I made 2 squares and then connected them with straight lines, right?
Yeah. So
At right angles.
another whole cube.
Yeah, so to make a hypercube, one way I could envision that is I could take a cube, and then I could take another cube, and this is where things get hard to draw.
And connect at every point.
Yeah, and then I need to connect the vertices with line segments, right?
Yeah.
So this one would need to get connected to that one,
Why don't you can you draw that?
and this one would need to get connected to that one. You can see it. My drawing's going to get messy here in a hurry, right? So like, I need to connect that, and this needs to be perpendicular on all counts, right? Which I can't draw on the board, but like I could think about. You guys see that?
Could you draw the cube, like a miniature version of the cube inside of the cube, and then connect up that? So
Yep.
it's all symmetrical and stuff.
Yeah, so that's called a tesseract,
Oh.
which is a realization of drawing this. So you could sacrifice size, right?
Yeah.
Because the deal with this one was that there were 2 squares of the same size, and then I connected them with right angle line segments, right? So one way I could think about doing this is I could, instead of drawing that other cube over there, I could just say, well, I'm going to envision it being the same size, and then I'm just going to connect the corners inside here. And every line that I've drawn, I'm just declaring these to be one long. Like that one's one long, this one's one long, that one's one long. And then I'm declaring all the angles to be perpendicular. Can I draw this?
No.
Not conveniently, right? Can I 3D print one? Yeah,
Whoa.
sure. Like this, it's pretty easy.
That's cool.
Cool. So that would be a math relevant shape that's of, yeah, I'd call that sufficient complexity. You can't do this one because there's a million of them.
Dang it.
Okay, but you could do something similar. So there are a bunch of other kind of higher dimensional objects. You could go find one and think about it.
Or like a hyper pyramid.
Yeah, sure. You could make a hypertetrahedron. In fact, there's a statue of a hypertetrahedron on my desk.
No.
That one's complicated.
Okay.
Well, so I'm lying to you a little bit. The thing there's a statue of on my desk is a little bit more complicated than that, but it is basically a hypertetrahedron.
Okay.
Cool?
Yep.
So this would be what your draft should consist of, right? It should be like half a page. I plan to make description of thing, right?
Yeah.
Maybe vague sketch. Cool. If you start making it in Tinkercad, just a screen cap of what you've got so far would be fine. Cool. I just want to know that you're working on this so that I don't get these at the like prototype day.
Yeah.
I don't want to get all of them that day and have to be like, so I'm going to pick on some people. Jeremiah, yours won't print, it's too thin. Zach, yours is overhanging too much. You need to add support, but you didn't plan on that and it won't work for some reason because it won't fit together after we put the support in there or something.
Well, really messed up.
Sorry, Jazz, yours needs to be cut into 7 pieces. Like, you have till the end of class to cut it into 7 pieces on Tinkercad. Like, no, you don't want to do this, right? Cool. So that's why I want the draft first. So I can be like, okay, yours is going to have to be cut into pieces. Yours definitely won't go on the printer. Like, it just, there's no way to make that shape happen. Cool?
Yes.
Or yours is a square. Like, that's not complicated enough. You need to do something cooler.